let's move on to more examples. Okay, now let's look at these two. Let's look at f. And I'm telling you that f is a function. What is f? F is a machine that is transforming elements of this set, which is the set of real numbers. And remember, this set is called the domain of the function. The domain is the set of the inputs, and it's just transforming them into another elements of another set, which in this case is also the real numbers, and is known as the codomain of the function. So let's analyze. F is taking the number 1 as input and is associating this input with the number 3 as output. So that's perfectly okay. Now it's taking the number 2 as input and it's giving you the number 5 as output. So for this element, there is only one associated number of the codomain, the number 5. Okay. And also, f is associating this input 3 with also the number 5, which is also okay. You have to understand this. You can associate one of the elements of the codomain to two possible inputs in the domain. That is perfectly okay, because what I said in the requirement was this. It's not possible to have two outputs for one input. This is the requirement, okay? It's not possible to have two outputs for one input, but it's perfectly possible to have two inputs associated for one output. Okay, that is perfectly okay. I can associate two inputs, in this case 2 and 3, with a single output. That is okay. Now let's go to G, this one. G is a machine, which I'm not gonna call a function because it's not, that takes elements of this set, the real numbers, into another elements of another set, also the real numbers. So let's see why I'm saying that G is not a function. Okay, look at this. 8 is being taken to 1/4. So one single output for this input. Now this element, 1/2, is being associated with just one output. That's perfectly okay. One single output for an input. But the violation occurs right here. The number 5 is being associated with two outputs, okay? The number 6 and the number -2. And this breaks the rule, the requirement, okay? Remember, we cannot have two outputs for a single input, okay? So I want you to understand the difference between what's happening right here, okay? We have one output being associated to two inputs, and I'm telling you that's perfectly fine. And what's happening right here, in which two outputs are being associated to one single input. That is what cannot occur in a function, and that's why G is not a function. I'm gonna give you some seconds to understand the difference between this and this. Understand it visually, okay? Okay, let's move on. Just pay attention. Notice that in these two cases and the others, the machines, they are taking elements of one set, the real numbers, into another set, which happens to be the same as the set of the domain. Okay, both domain and codomain are the set of real numbers, but that doesn't have to be always the case, which is the next example. Look, in here, D is a function that is taking elements of the set of real numbers, and that's the domain, this set, and it's taking them to the set of the natural numbers, the codomain. Let's see what D is doing. Look at this. It's taking the number 23 as input, and it gives you as output the number 2. It's taking the number 2.1 as an input, and D transforms it into the output 2. And look at these other two associations. It's taking the number 1.83 and it gives you as output the number 3, and it's taking the number 1328 and it gives you as output the number 4. Can you guess what this machine is doing? What type of process it's doing on the inputs? What this machine is doing is taking a number, a real number, and what the machine is doing is giving you as output the number of digits on such number. Can you see? This is the number of digits in this number and this number. This is the number of digits in this number, and this is the number of digits in this number. So that's what this machine is doing. And why do I say that this is a function? Because it only associates one output for every single input. Okay, for this input, it associates 2, only one output. For this input, it associates 2, only one output. For this one, only one output. For this one, only one output. Okay, so that's why D classifies as a function. Okay, so that was the definition of a function. Is a machine that takes inputs into outputs with the requirement that for every single input you can only have one output. Only one output, no more than one. Okay, let's go into number 2. Point number 2, the terminology and notation for functions. So let's suppose this. Suppose f is the function that takes a number as input and it gives you the double of the number as an output. Okay, we already talked about this function. Okay, that was the first function that we talked about. We called it f. Okay, and what this function is doing is it receives the number x, and as output it will give you the number, the number 2x. Okay, so it takes the number x and it produces the number 2x as output. So it associates this output to this input. Okay, now let me tell you about some terminology and notation for functions. If you notice, one more time, what this machine is doing is taking this input x and it's giving you as output the number 2x. And we usually represent this in the form of an equation. And we're going to write this. Pay a lot of attention. I'm going to write this. And I'm going to pay attention to how I pronounce it. F of x equals 2x. I repeat, f of x equals 2x. This is what we say usually in mathematics. This is what we talk about, okay, this phrase. Also, I can also say this other phrase. The value of f in the number x is the number 2x. Or the function f takes as input the number x and as output gives you the number 2x. Okay, there are several ways to talk about this equation in this context, and you will get those phrases, you will get familiar by just listening to me pronunciating them. Okay, so don't worry, I'm gonna repeat those phrases. F of x equals 2x, or the value of the value of f in x is 2x. This is the name of the function. This is what is known as the argument of the function. So basically it's the input. Okay, when you listen to the word argument or you read it, that's basically the input. And this, all of this is known as the value of the function, okay, or the output for this specific input, okay. So let me tell you how this works. For example, what does this function give you when you give it the number 2? It's going to give you the number 4, right? So we represent that in this following way. The function f into the value of the function f for the argument equal to 2 is 2 times 2, which is equal to 4, right? So the value of the function in this argument is this. The function takes this input and it produces this output. Okay, perfect. So that is the terminology. I repeat, this is the name of the function, this is the argument or the input of the function. Try to memorize these words. And all of this is known as the value of the function. Perfect. Now, for the last part of this class, we're going to talk about the evaluation of functions, which I already did in the last example. Okay? And I'm not going to explain you what this is. I'm going to do it and you will understand what I mean. So the instruction is this. Evaluate the given functions in the given values. I'm being given this function f of x. Remember how it's pronounced? F of x equals to x. And I'm being told to evaluate this function for this value of the argument for x equals 4. So all we have to do is this. I'm going to substitute the value of the argument in here and also in here, right? So I'm saying this. F of 4 equals 2 times 4, which is 8. So in the end, f of 4 equals 8. F of 4 equals 8. I should have written the word. It doesn't matter. Okay, f of 4 equals 8. Repeat, f of 4 equals 8. And what I say is that I have evaluated the function f in the argument 4. And the result is the output 8. Okay, f of 4 equals 8. F of x equals to x. You will get familiar with this. I guarantee that to you. Okay, don't worry too much. Another example. I'm going to pronounce this. G of x equals to x. So this function is the function that takes a number as an input and it produces the double of such number. Okay, so let's calculate this function into this value. It's actually the same one, right, as before. Yeah, I made that mistake. Well, let's do it. No, it's actually the same. Sorry about this. Let's go into h. So this function, the function h, is read as follows. H of x equals 2 times x squared minus x. In other words, h is the function that takes this argument or this input and as output it will produce all of this. 2 times x squared minus x. Okay? And I'm being told to evaluate the function h in this argument in the value of x equals minus 1. So let's do it. I'm gonna pronounce as I write. H of minus 1 equals 2 times minus 1 squared minus minus 1. So if you can see, I'm basically substituting this value everywhere that I encounter an x in this equation. Okay, and that's it. All I have to do next is just operate all of this thing, all of this expression, calculate it, and that's it. So let's do it. This is a 2 minus 1 to the squared is 1, minus times minus 1 is plus 1. So this is 2 times 2, which is 4. So we say the following: h of minus 1 equals 4. H is the machine or the function that transforms this input, the input minus 1, into the output 4. And in the representation of sets, what H is doing is this. It's taking this number, this element of this set, remember this is the domain of the function, and it's transforming it into the output 4 of this set, which is called the codomain. There are many words for you to learn today. Okay, that's what this machine is doing, or this function. Okay, now what about going backwards? Okay, look at this. Look at this other exercise. Number 2, find the value of the argument such that when evaluated in the function gives you the given result. So now this is the backwards process. I have a function f of x equals x to the cube, and I'm being said that for some particular value of the argument, f of x equals 8. So I'm being given the output. You see, this is the output, and I'm being asked to find the input such that it produces this output. You see? Okay, so let's see how this works. I'm gonna write again the function f of x equals x to the cube, and I'm being told that f of x equals 8. So I'm gonna substitute that in here. F of x is gonna be 8 equal to x to the cube, and all I have to do next is simply solve this equation, right? And as you may know, the solution will be 2, because 2 to the cube will be 8. So this is the value of the argument such that when evaluated into this function, look, when I evaluate the function in this number, I'm gonna have this. Which is in fact what I was told. Okay, so the argument that produces such number is 2. Another one. Now I'm giving you another variable. Instead of x, I'm calling it y. This is for this reason. Don't get married to x's. Okay, like don't think that x has a specific or a special position in these things. Okay, this, when I say this g of y equals y minus 2, I'm basically saying the same as this, g of x equals x minus 2, or g of a equals a minus 2. You have to understand the following: the variables are just dummies. Okay, they don't really mean anything. All that this thing is telling you is that g is a function that takes a number, and as output it will give you such number minus 2. That's all that this is saying. There is nothing special about what letter I use for the argument. Nothing special. This thing is exactly the same thing as this, and exactly the same thing as this. Okay, there is nothing special about the letters. All of these functions are the functions that take one number, and as output it will give you such number minus 2. Can you see? So don't get married to x's. This is hard to understand, but you will have to. Okay, there is nothing special about the name that you give to a number. Okay, so let's solve this problem. So we know that g of y equals y minus 2. And I also know that g of y equals 4. So I need to find this input y such that when I evaluate the function in such input, it gives me as output the number 4. So let's do it. G of y equals y minus 2. But I know that g of y is 4, so I substitute that equals y minus 2, and then I just solve this equation, which is a simple equation, and it's gonna be 6. Okay, so this is the result. When I evaluate g in 6, I'm gonna find as the result 6 minus 2, which is equal to 4, like I was told. So this is the result. This is the answer. And one final example, are more a little more complex. So h of w equals w squared minus 1, which would have been the same if I would have written h of x equals x squared minus 1, or h of uh, z equals z squared minus 1. All these things mean exactly the same. So let's evaluate this function. Sorry, let's find out what input produces this output. Okay, so I know that h of w has to be 99, so I substitute it, and then I simply solve this equation. Okay, this is gonna be 100 equals w squared, and when I solve this equation, I get w equals plus and minus 10. Okay, why plus and minus? Because 10 to the square is 100, and minus 10 to the square is 100. So we have two possibilities: y equals 10 or y equals minus 10. We have two solutions to this problem. Both of these inputs will produce this output. Okay, h of 10 will be 99, and h of minus 10 will also be 99. Okay, so this is how evaluation of functions works. And that's it, guys. Okay, I hope you have understood most of these things. This is a very new concept for you, the concept of functions, and it's a very important topic in mathematics. Actually, a lot of mathematicians and scientists have said throughout history that all that mathematics does is just studying functions. Okay, mathematics is just the study of functions. I didn't say that. Okay, a lot of important people said that. Um, and so it's very important, and it's a necessity when you enter into calculus in fourth or fifth semester. The idea behind calculus, I'm gonna write it here. Calculus needs three things in order to be studied: the concept of number, the concept of function, and the concept of limit. I don't know if you have heard about this branch of mathematics, calculus. It's very popular, very important. To me, in my opinion, this is one of the greatest achievements of mathematics. It's a great tool. It's phenomenal. And all you need in order to understand calculus are these three concepts: number, which you already understand to a certain extent, and now you need to understand function, which we're gonna understand in this semester, and then limit. Okay, and when you put together these three things, you can do calculus, and you can solve amazing problems with this tool. You can do crazy stuff. Okay, I like this thing a lot, and it's been said that calculus was the mathematical tool that enabled us to go to the moon and do a lot of crazy things, okay, to construct computers and so on. So this is really cool, and you need functions, okay, in order to study this branch.